Hello, everyone, and we are on to day 2 of adding and subtracting rational expressions today. And I understand yesterday was probably a little bit challenging, and today we're going to talk through some of that and also look at problems that aren't as simple as just multiply by the opposite denominator. So we have 2 fraction examples here. And you're probably wondering why in the corner there's a picture of a crying child. We'll get there in a moment. But for now, I just want to talk about these special circumstances in fractions where you don't want to just multiply by the opposite denominator. Because in this case, if you look at the first problem, 7/8 plus 5/16, you'd be looking at a common denominator of 128 if you multiplied both sides by 16 and by 8 respectively. Most of you, though, look at that and go, wait a minute, there's a lot easier way to do this. I can make my denominators be 16, and it's going to be a whole lot nicer and easier to work with, because I can just multiply this fraction by 2 on top and bottom, multiply this fraction by nothing, because 5/16 can stay the same, and then you simply add those together, making 19/16. That's a much easier fraction to work with than something that is going to be over 128 and require a lot of reducing. So in some cases, the method of multiply by the opposite denominator, while it will work, it's going to make your life way more difficult. And to do so with the rational stuff we're going to be working with today would make the problems nearly impossible. So another way to think about common denominators is to think about factors. And that's why you're going to see this picture of the children in the corner that we're going to get to in a second. But if we think of the factors of 6 as 3 times 2, and the factors of 4 as 2 times 2, you'll notice they both have a 2 in them. Okay? And this is going to help some of you that have been looking at fractions for years and saying, I've really struggled with these because I don't know what 6 and 4 both go into. That's hard for me. Well, you can use factors and consider fractions like petulant children. And children often cry when they don't get their way, they throw a fit, and they get upset when they don't get their way. So what we're going to do is we're going to look at denominators as if they're petulant children, and we're going to act as horrible parents that just give in to their children. So what we're going to do is we're going to look at this 6 broken down into its factors, and it's looking over at 4 and saying, it's not fair. He has 2 2s. I only have 1 2. So to make it fair, we need to give him another 2, because it's all about being fair with fractions. So if I times by 2 on the top, on bottom, I'm also going to times by 2 on the top, making that 10/12. Now you look at the fraction on the right in its factored form. It has 2 2s. It looks at the 6 and says, it's not fair. That 6 has a 3, and I don't have a 3. So like I said, we're going to act as terrible parents, and we're going to give a 3 to both the top and the bottom. And so now you notice both denominators, a 2, and a 3, a 2, a 2, and a 3. The denominators are now equal and even. So by multiplying the left side by 2 and the right side by 3, we've made the denominators the same. For some of you, you can look at 6 and 4 and just see, oh, 12 is the common denominator. For others, it's much more difficult, and so using factors makes that easier. And this factoring form is what we're going to have to use to be able to make rational expressions the same. So we're going to look at 3 examples today where we're going to try to make the denominators the same through factoring. We're going to be bad parents to petulant children, and we're going to make all the denominators the same by giving them exactly what they want. All right, so example 1 here is a little more challenging than what you saw yesterday. And by the way, this is my favorite picture of a petulant child. But as we look at the problem here, the denominator on the left, it does not have anything to factor. 4x is in its simplest factored form. However, the 2x cubed plus 8x squared plus 20x, hopefully you all look at that and say, oh, those are all even numbers and all three terms have an x. So I can take out an x. I can write it as 2x times x squared plus 4x plus 10 by dividing everything in the problem by 2x. So now we want to look at the left side and the right side. On the left, we have 4x as a denominator. That side is mad because that side thinks it's unfair that the right side gets to have this x squared plus 4x plus 10. So we're going to give it x squared plus 4x plus 10 on this left side. And I'm going to have to write a little bit diagonally here to make this fit. But you'll now see that we have x squared plus 4x plus 10 given to the left side. But now, when we look at the denominator over there, you have a 4x times x squared plus 4x plus 10. On the right side, they only have a 2x times x squared plus 4x plus 10. So they need another 2 in order to make them the same, because 2 times 2x would make it 4x. So we've now looked at these petulant children that are mad because they don't have what the other one has, and we give it to them. So we've now made our common denominators, and we can just work with the tops. On the top of the left side, we distribute a 5 through that parenthesis, making it 5x squared plus 20x plus 50. And our denominator, oops, sorry about that. Let's see if I can get your screen back. There we go. Now, your denominator is going to be 4x times x squared plus 4x plus 10. That's your common denominator. On the right side of the fraction, your denominator again is 4x times x squared plus 4x plus 10. By factoring them, we could find that what they were missing to become common denominators, and we give that to them. Now, we have to times this 2 by the top over here. Luckily, the top was just 6. So 6 times 2 is just 12. And now our final step, the adding of the fractions, is actually the easiest part. That's just combining like terms. So we've put the left fraction and the right fraction combined. The 5x squared and the 20x have nothing to go with. Then we have 50 plus 12 is 62 over 4x times x squared plus 4x plus 10. For some people, this is a harder one because it isn't laid out quite as easy as some of the others are. But the point is, factor the bottoms, find what would make them the same, and then combine your like terms. Let's move on to the next example. So we said in order to add and subtract, we need the denominators to be the same. But in order to make them the same, we have to first recognize what are the factors of the denominators in order to make them the same. So on the left side, we have a trinomial that can be factored. X squared plus 5x plus 6 can be written as x plus 3 times x plus 2. So this is where we recognize actually an easier example. Because on the left side, hopefully we all recognize we have an x plus 3 that's also on the right side. So the child on the left side looks at the right side and says, you have an x plus 3, so do I. I don't care about you, we're the same already. But the one on the right side gets upset because it looks at the left fraction and says, well, we both have an x plus 3, but you have an x plus 2. That's not fair. So to make it fair, we give the right side an x plus 2 because fractions are simply petulant children. They want what someone else has. So we're going to give them what the other side had in order to make them the same. So our common denominator was x plus 3 times x plus 2. And on the right side, we have to do some work. The left side stayed the same because it didn't need to change, much like our first fraction example. But on the right side, we needed to give that an x plus 2. So we end up with 2x plus 4 over x plus 3 times x plus 2. All right, the final step is to subtract. And remember, when we subtract, we treat it like parentheses where you have to distribute the subtraction. So we do 3x minus 2x is 1x, negative 7 minus 4 is negative 11, and your answer is x minus 11 over x plus 3, x plus 2. All right, that was challenging. Now we have one more example. I know this is a longer video today, but this is a difficult topic. We're going to try to zip through one more example. All right, here we go. We're going to follow the same process as every other time. To figure out what the bottoms have in common, we need to factor the bottoms. So I go ahead and factor x squared plus 6x minus 16 to x plus 8 times x minus 2. The right side, numbers that multiply to negative 7 and add to positive 10 are negative 2 and negative 5. So again, we're going to act out the petulant children here. Look at the denominators, and they're jealous of each other. The left side has x plus 8 and x minus 2, but it does not have an x minus 5, and the right side does. So we give the left side an x minus 5 in order to make them the same. The right side looks at the left side and says, wait a minute, you have an x plus 8 and I don't. That's not fair. Because common denominators are as simple as giving in to a petulant child. All right, now we have some algebra work ahead of us. We have to distribute out the top, making it 2x squared minus 10x and plus 5x makes negative 5x. And 5 times negative 5 is negative 25. And the denominator is going to be 3 terms, x plus 8, x minus 2, and x minus 5. The second fraction, we distribute 3x squared plus 24x. Sorry, this writing with the finger thing, I understand it's not always the neatest, and I apologize for that. But the denominator is now always going to be the same. X plus 8, x minus 2, x minus 5. So we factored, found what they had in common, and said, we don't need to give them stuff they already have. They want what they don't have. So we gave them what they didn't have. Now it's simple subtraction. 2x squared minus 3x squared is negative 1x squared. Negative 5x minus 24x is negative 29x. And the negative 25 had nothing to go with. So our final answer in the ultimate subtraction problem is negative x squared minus 29x minus 25 over x plus 8 times x minus 2 times x minus 5. I apologize, this is the longest video we will do. This is a challenging topic, and hopefully you've had enough practice with it. We're going to review tomorrow together, and we will take the quiz on the following class after the review.